So in this series of videos, I'm going to go over our Unit 2 test and kind of show you how to do each problem. The unit test retake questions are just these questions kind of modified slightly. So if you can understand how to do these ones, you'll be able to do them with different numbers or slightly different things going on. All right, so first up, I'm going to zoom around the page. All right, so this first one, we had this function defined this way, and basically it's telling you our options are 0 and 1. We're trying to figure out which type of discontinuities or whatnot there are. So the discontinuities are going to happen when the bottom of the function equals 0. So it's an x squared minus x equals 0. And if I factor this, I see that's at 1 and 0. All right, so 1 and 0 are the discontinuities. So automatically, I think there's one that says f is continuous at 0. D is automatically out because it's not continuous at 0 because I'd be divide by 0 if I plugged in 0. But now I have to figure out if they're removable, jump, or vertical asymptotes. And to figure that out, I have to factor the entire thing. So on the top of this rational, I can factor out an x squared. Plus 2. And then I can cancel out. All right, so if I cancel out that one factor of x, I get this function. All right, so when I simplify, only the x minus 1 is on the bottom. So after you simplify, anything that's left on the bottom, that's going to give you an asymptote. All right, so we're going to have an asymptote at 1. And then anything that did cancel out that was x, that's going to give you a removable. All right, so because the x canceled out, at 0, we're going to have our removable discontinuity. At 1, we're going to have a vertical asymptote, and that makes C the right answer. Right? Because it's removable at 1 and vertical asymptote, or sorry, removable at 0, vertical asymptote at 1. All right, so that's how you do question 1. All right, question 2. All right, what are the values that f has a removable discontinuity? So there's 3 different types of discontinuities. They're removable, where the limit exists. There's jump, where your function jumps from one thing to another, and there's asymptotes, where your function goes to infinity or maybe negative infinity. All right, so those are different types of discontinuities. We're just looking for removable ones here. Well, one's going to happen right here because that's pretty much the exact same picture I drew in green. Here, there's a discontinuity, but this is a jump one, so this is not one of the answers we want for this specific problem because it's a jump discontinuity. But here, again, we have something similar to the picture I drew. We could just basically fill in this hole, and we would fix the problem of discontinuity, and that's why it's called removable. So the removable ones happen at 1 and 7. All right, this one, whenever absolute values are involved, you have to kind of just think about what's going to happen in the negative side and the positive side. So let's focus on the positive side. So if I plug in a positive number into the absolute value of x, the absolute value just doesn't do anything. So that simplifies to 1. So if I started this with a positive number, I would get 1. What about a negative number? All right, with a negative number, the absolute value changes the negative into a positive. So it's going to keep the top's going to be negative, but the absolute value is going to turn the bottom into a positive, and that's going to give me negative 1. So for every positive number, it's going to equal 1. For every negative number, it's going to equal negative 1, which means the graph would look something like this. I can't plug in 0. So what happens? I'm going to have a jump discontinuity at 0. All right, it's not removable because there's a gap. It's not infinite because these are kind of canceling out in a way. All right, and this one gives you a jump. So jumps happen a lot with these absolute values because the positive and negative kind of causes 2 different things to happen. And lastly, we have our short answer. All right, identify all discontinuities and then classify each one. So as we saw in question 1, the discontinuities happen when the bottom of our fraction equals 0. So that's going to happen at x equals 1, x equals 3, and x equals negative 4. All right, so that's half the question, is just knowing those are our discontinuities. And then what type are they? Well, we have to figure out, are they going to cancel out or not? So if you factor the top, x plus 4 times x minus 1, all over that bottom. So the x plus 4 part and the x minus 1 part would cancel out, which means those are not asymptotes. These two are removable. All right, so if it does cancel out, it's removable. If it doesn't cancel out, so x minus 3 would still be left on the bottom, that's when it's, well, for us, we call it an infinite discontinuity. All right, there's an asymptote there. It's an infinite discontinuity. All right, so this is how you're going to do the first page of the test. All right, there's a lot of kind of figuring out where things cancel out. If they cancel out, it's removable. If they don't cancel out, it's an asymptote. All right, the only one that's different is this one with the absolute value. Absolute values are always a little weird. All right, for question 5, all right, let this piecewise function be defined. Which of the following statements is false? So all the statements are about it being continuous. So we're just going to figure out where is this function discontinuous. Right. Well, first of all, 2 happens right in the middle of this function, which is a polynomial. So 2 is definitely continuous. 4 happens at the bottom here after 3. And again, it's just a polynomial that we're plugged into. So it's definitely not D. So we have to figure out which of these changes where we change from one piecewise to another are going to be continuous. So the first one happens at 1. So I'm going to plug 1 into this, and that gives me 5. I'm also going to plug 1 into the next piece where it switches to, and that's also going to give me 5. So at 1, all 3 of these are equal to 5, which means it is going to be continuous. All right, so that's not false. So the answer should be C, but let's just double check, because if I plug 3 into this, that's going to give me -3, 3 into the bottom, that also gives me -3, so it looks like that's fine, because when I go from here to here, I get -3, but right in the middle, right at 3, I'm 4. So my graph would look something like this. It's -3, and then at that value, it's 4, which is a discontinuity. All right, so C is the correct answer because it's not actually continuous at 3. Again, this question is very similar. I was saying, where is this function continuous? All right, is it continuous at -2 or +2? So at -2, we're switching between these top ones. And this one's going to give me -6 plus 1 is -5. And I plug in -2 into that middle one. -8 plus 3 is -5. All right, so we are continuous at -1, so that's good. I just try the same thing with 2. So I'm plugging 2 into the middle one, and then 2 into the bottom one. And those things are not equal, which means it's not continuous at 2 because there's a jump between those pieces of the piecewise. So the only answer is just 1 is right. And so again, with all these piecewise, when you're talking about continuity, you're thinking about when do the piecewise line up nicely, that's when it's continuous. If they don't line up nicely, it's discontinuous. All right, so let f be this function for which of the following is f not continuous. It's just another rational function. All that matters for continuity in general for rational functions is when the bottom equals 0. What happens at 2 and -1. Right. And there's nothing else we have to do in this one because we're not classifying them. It would end up being just a removable one here and an asymptote here. I didn't ask for that. It just asked where are the discontinuities. It's those two. All right, and 8 is just asking for the definition of being continuous. There's 2 things that I think that happen first. All right, first, you need to be able to plug in your value. Second, you need to be able to have a limit at that value. And third, all right, those 2 things are equal to each other. All right, so those are the 3 conditions of being continuous. Your function value exists, your limit exists, and those 2 things are equal to each other.